I'd like to give the mic to our authors actually, because I think they did a great job on this one. They've touched all the modern practices we're aware of. But let's discuss what this means. Yeah.
Yeah, sure. I mean, obviously you can also find there an entire full books and lectures on cost management and how you deal with cloud costs, going up to FinOps and stuff like that. So we really thought about okay, what is the bare minimum which you should consider to have in mind when you build a platform so that you can bring it into the platform early on and can leverage it as soon as you're ready for it, as soon as someone is asking for it, and so on. So that's why we stripped it down to a few key elements, thinking about what are the influence on costs, talk here a little bit about it, going a little bit into deeper perspective of the tagging strategy.
Can I quickly ask a question? I was really wondering how you wrote this chapter, like who was participating in writing it, because I think it's a really thorough one. like all of it, although.
Yeah, well, it's come from out of my feather primarily. Also because that's what we do, or it's one part of our principle when we build platforms or when we do cloud projects, to early on keep such principles, such approach in mind. Because I don't know, for many people who are working in cloud environments, let's say the last 10 years, somehow the early years were always so kind of discovery phase, I would say. And at some point in time, costs turned away, so no one cared about it because no one saw really the bill in the end. And the last 3 years, 4 years maybe, the cost awareness has raised drastically, and is also continuously getting more and more pushed back to the teams, more on an operational level, more on an implementational level. And so we are also kind of try to follow this demand, but we try to keep it in a, I would say, more practical way, so that you can get an early understanding of it, and not, I don't know, need to study the cost explorer of a cloud provider whatsoever, but that you can directly get started with a few ideas how you can generate visibility if you really, really need it, so that it also works across either cloud provider plus Kubernetes and so on.
Yeah. I guess this chapter kind of lays the groundwork for understanding cloud versus on-prem infrastructure costs, or decisions maybe.
Yeah.
I was thinking, because you also are touching the topic of repatriation. Do you want to expand on this a little bit? Do you think the narrative around cloud being always cheaper is shifting now?
Well, I'm not sure. In my world, no one really claims that cloud is cheaper. People more say cloud is simpler. But I mean, David Heinemeier Hansen is very openly and transparently about their cost perspective, and I think he just last week or 2 weeks ago or so, he gave an update on the storage which they have also demigrated from the cloud, and how much money they're going to save. And I can say from my past experience, especially if you have very large data, like petabytes of working data, not of just laying in rest, it will be always cheaper to go off the cloud. There's no way the cloud is more cheaper. It simply doesn't work like that, because it's very cheap nowadays to buy storage technology. Just throw it somewhere. And if you want to have it redundant, even then it's cheaper. You can clone it 3 times, 4 times. It will be most of the time always cheaper in that case. I was working before in a media company. We had around 24, 25 petabyte of storage. There's a simple math behind it, even with very good contracts migrating to the cloud. would cost us 7 times more per year to have it in the cloud than if we put the storage in 3 of our data centers. And then, yes, of course, always people come with like, oh, but you need people to maintain it. You need people for cloud too. It's not that cloud is a magic unicorn that runs by itself and you don't need anyone doing it. That's a lie. If someone comes with that point, it's maybe I've never done really cloud in a large-scale enterprise. There's for sure a few batteries included, a few functionalities where you need less to worry about, right? So if you think about doing backups and stuff like that, it's often in some way already proved. But I also have seen company failing if they do disaster recovery and they tried it through, that it still didn't work on the cloud perfectly. And then they run into big problems. We try to catch up here on this topic, and repatriation is like this movement of going down from the cloud, going either to an infrastructure or service provider, a regional one. I think in Europe you have a couple of options where if you take a look on just the pure server costs, they're incredible cheap, but they're still in some way managed also. So it's not like that it's like entirely yours thing where you have to take care about the wires and stuff like that. And yeah, there's a good amount of options which you can always consider.
Just one quick question. I really don't want to take too much time, but when you say repatriation, for a company who has always been on cloud and who wants to try this, how do you build a team? Like, would it be a problem in the future? Like, it keeps coming to me. Okay, do you actually lose talent in there, or where do you know where to start from, right?
Well, I think it also slightly depends on where you have started the education for each and everyone. When I did my bachelor studies, the first, I don't know, 2 or 3 semesters, we spent with like the groundwork of information technology, which was almost like electrical engineering. And you still were learning how to put somehow a server somewhere. For sure, you didn't learn how to operate a data center, right? But also nowadays, not every company is running in an entire data center. That's also not like it is. You go to providers who own the big warehouses that are specially protected, and you buy your rack in that warehouse. And you even can get the service like, hey, I ship you my server, please cable it up, and that's it. So again, like this, you don't really need to consider to start by 0. If you want to do that, for sure you can also do that. And actually, it's not that costly.
That was the David's scenario, right? They were building it from scratch in their own space, I guess.
Yeah, absolutely. And I mean, also there you can get used hardware, which got in the past retired after 3 years. Now they have extended to 5 years, but you could get very, very strong server that are still good for practically no money. So if you want to really rack your things up by yourself, the initial costs are fairly okay. Of course, you should find an electricity provider who doesn't give you the worst rates for your electricity. But other than that, to really experiment around with it is a thing of like a few €1,000. For a company, it's okay.
Okay, thank you. Yeah, I guess there is an assessment, like topics list, like ideas, criterias, I guess you were putting in here for costs.
Yeah, exactly. Some food for thought, right? To think about what are all the relevant aspects in it. You can see scalability, reliability, and stuff like that. I try to avoid a little bit the perspective high availability. I do not like this term very much because usually
why?
People have the wrong understanding of high availability. If you ask like how high available should it be, is 99.0 enough, or should it be 99.9? But at this percentage there is no understanding what means every 9 which I add to it. We had a customer who asked us, I would like to have the availability of my application in a cloud service of 5 nines, so 99.999%. Correct me if I'm wrong, but I think this is like 12 seconds per month or something, which the application is not reachable.
Mm-hmm.
I'm not very good with math, but I have done a lot of calculation on the availabilities per SLA and contract you get from a cloud provider. I cannot guarantee you that. There's no way in this world how you can do that. And therefore, I'm not a huge fan of this high availability thing because for the most use cases, customers are very forgiving if your service is for a minute not available. For sure, someone from the business will come and tell, hey, we lost now, I don't know, 100,000 euro. But that's also always just on the theoretical paper. If you have solutions around it, which can maybe still can catch up, like, hey, we have seen that a customer tried to order something, but because the service was not available, then you can come back to the customer later and say, like, sorry, we had a short outage. Here's
Here's
the
the
thing.
coupon. Yeah.
Yeah. And it's not a problem, right? The thing is that most of the time there's the possibility that it will still be cheaper for you operational wise to go that way rather than to go all in for an extreme high availability just to catch the last customer who maybe order for €8.99 somewhere or something.
Yeah. Yeah. We a few years ago in DevOps Eindhoven event, there were open spaces for people to pick up a topic and then get together and discuss. I think the room I was in, we picked the topic as how many nines are good enough for your daily life. Like, what does it mean for you? So people started thinking, you know what, I actually don't go on this app that much. So
Yeah. And I mean, you can always differentiate. I mean, in Europe, meanwhile, the SOS button on your car is obligatory. You need to have it. And if you push the button, someone needs to answer that call, right?
Yeah, then there's this kind
And,
of
and there's a stupid amount
regulations.
of
Yeah.
IT systems behind it. But sometimes I think, like, why don't we have just a good old phone line? Just like call a number and it gets redistributed to a couple of phones. And I mean, it almost never fails, except there's really an electricity outage, but then data center most likely also down.
Yeah.
You can always over-engineer the stuff. And that's the problem with the extreme high availability thing.
Mhm. Also, there's the fact that you might design your systems to be reachable with 5 nines, and then, yeah, the wireless networks of end users or their phones or like their versions of OS, and the model that doesn't fit, like you might have other issues, right?
Yep.
Yeah. So
You need to go in other architecture. Usually it's more expensive. And we say, like, a big thumb rule, the more nines you add, for every 9 you add, you can practically double the costs. It's maybe not realistic,
yeah,
but for a rough idea, if you want to jump from 99.9% to 99.99%, usually you need to have an active replication. Usually you need to have an application that is as a backup running continuously in a scaled mode, because scaling in a cloud still takes too long if you really need to scale large systems, right?
yeah,
Bringing up an VM usually 5 to 10 minutes, depending on where you're hosting. So there comes a lot of extreme amount of costs with it just to provide this. And then if you do cost-driven analysis of it, you might find out, okay, maybe it's equals. So
yeah. Okay, let's not dwell too much on the need, because that can be questionable, or like it might depend on the business, I guess. But let's go on the models you've suggested. But first, there is the hidden costs as well. We need to think, right?
yeah. That's the hidden costs, or the costs which are extremely hard to estimate. If we talk about like platform engineering and creating huge platforms. They usually also maybe distributed either throughout a country or either throughout the whole continent. And then costs for API gateways, maybe outbound or egress traffic, data that needs to be replicated or transit, and so on. It's often very, very hard to really give a good number about that. How high is it? How much does it really influence the costs in some perspectives? And yeah.
Yeah. This was also I couldn't highlight this one. Yeah, this is also interesting. All the services you actually don't create meaningful boundaries around might just explode. Once in one of my clients, we were testing an architecture between, I think, accounts. We were trying to, I don't want to name the product or the cloud provider, but I think one of my engineers left the test cluster turned on over the weekend, and I think it cost the customer 10,000 euros or maybe it was a long weekend for 3 days. I was surprised they didn't have alarms.
Happens fast.
Yeah.
Happens super fast. We also had like many
They were
years
really
ago
kind to
junior
us, so they
consultants, the
didn't
same
make
problem.
they didn't make us pay, but they could have.
Actually, I need to be very fair here. I have very good experience with almost every cloud provider when you say like, oops, sorry, we really, really did here a mistake and it was not intended. And maybe you could give us some discount on the cost or so. They very often are very fair in that regards and say like, okay, we understand, fine.
Yeah, you're right. Actually, these mistakes happen quite often, and I think if you reach out to the right account team, you usually get a really positive response. Yeah, you're right. One question, I really didn't get what this meant. Ideal cloud projects, and we have to emphasize here what we're talking about. Things with a deadline are strictly opinionated. So yeah, following the best practices of the cloud provider. I'm not sure I get it, but what does it mean?
Let me shortly think through what I've written here. Ideal cloud
It's like
projects.
a deadline, like things with a deadline. So cloud projects, it makes it like ideal cloud projects should come with a deadline.
So the thing is more like the underlining the point of a project, right? I always say, and I think we wrote it also in the beginning, a project has a deadline, and when you hit it, it's dead. That's why it's called deadline. It's not that you go live, you go in production. But what happens is that it turns away all of your budget, all of the time you can put into, and it's turned to the next project.
Okay. I think you're connecting it to this earlier concept of projects mean there is a deadline, and then you have to be certain about the scope, etc. Okay, cool. So, and then we need transparency, right? There are I think this is AWS Cost Explorer. Then there are commercial solutions like Aptio Cloudability, and open source options, which every solution apparently comes with a trade-off, I reckon. But how do you see it in your own experience?
I need to say that for the open source alternatives, they are well meant. They are not a solution, I would say. Like you can use it if you have like a tiny cluster. You don't care so much about details whatsoever. They are good with that, but they are not a solution that you can run if you are a grown digital native company, if you're an enterprise, even mid-sized hidden champion with hundreds of servers and whatsoever. For those, the tools like KubeCost and OpenCosts do not come with enough details that I would say they are beneficial. Then I can just also go to the cloud provider cost center and just analyze there. this gives me the same details or even more insights.
Yeah.
I understand that it's a good business. I understand that the tools, frameworks are donated by companies that have a commercial perspective on it. Completely fine. Yeah, you can do it different ways.
Yeah. There's a question from the audience. Typhon asks, are there any enterprises who prefer cloud only for disaster recovery center? How feasible is it?
Are there any who prefer cloud only for disaster recovery center? So that
How do you know it's gonna work? Yeah, do you really need to do proper drills, I reckon.
But wouldn't this be the same anyway, whether it's you're using a cloud or another data center for disaster recovery? What's the diff? I think what would be the difference?
Maybe Typhon, if you feel like turning on your mic, you can elaborate on your question a little bit.
Yes, I can. Preparing the disaster recovery, which works as active is not so easy. So most of the time, if you prefer the easiest one as active passive, active standby, so the costs are so much. All the disaster recovery center lying there, but no workloads working there, so it can be more expensive. And I'm trying to understand that if some cloud option can be feasible for the disaster recovery setup.
Okay. Well, I think we need to shortly differentiate, because what you're talking about then more about, I guess, is like a fail-safe or having a duplicated setup which can run, because for the DR you usually would more consider to restore what you have wherever it is running. And then I think what I understand is more like you talk about a fail-safe. Actually, I know one company that has the possibility to go in a fail-safe mode to a cloud provider if the entire on-prem environment is gone. But it also has the reason that they are very close to an extreme large river. They are far away enough to not get flooded. The data center is even waterproofed for that case. But in the very unlikely case that still something goes wrong or everything goes wrong, they have a failsafe to go into the cloud. The problem is they have an extreme amount of data. And so what they have running in their failsafe is only good enough for 72 hours. After that, they do not have enough data anymore in the cloud, and they are done. Right. So
very interesting case.
Yeah, but again, it's the problem that shifting all the data to the cloud is so extremely expensive that it doesn't worth it.
Yeah, I mean, to me it feels like a multi-cloud model, to be able to run this. So multi-cloud is already hard in its nature. So if you're already building for multi-cloud, why not use it for all the things, would be my, I guess, answer for this. Why not use it for the things you don't have to build yourself, or like for innovation, etc. Like whatever positive things you might get out of cloud will be within your reach, but only for disaster.
Yeah, but I mean, this are actually very good cases where you would say where cloud is extremely attractive. Is that if your business is running in an area that is continuously struck by natural catastrophes, then hosting your stuff in a cloud environment is an absolute right thing to consider, because usually the regions you host in, the availability zones, are very far away from each other. And the data centers, at least what I've seen in Europe, are normally built on areas where you almost never see real natural catastrophes.
Right?
Yeah. But there are corners on this planet where
Exactly.
I'm located in South Germany, in Munich, and here you don't see any real natural catastrophe. But if I go 100 kilometer to the northeast, whereas one of the largest river, the Donau in German called, goes through, that river goes frequently over the edge of the riverbed and is flooding entire cities and areas.
Really?
So
Okay.
if you are a company located there, I would not recommend you to build a data center because, well, the chance that you get flooded is extremely high, right? But I mean, on the other hand side, companies are not stupid. They will evaluate that. But then cloud is really, I think, an extreme good approach. Naja.
Thank you. Yeah, interesting cases you made me and the audience think about, I think. And FinOps and cost management is the next one. I really would like to be able to cover the whole thing if we can. So that's why I'm kind of trying to keep up speed. So this is the FinOps framework by the FinOps Foundation. Any highlights you want to mention here?
Well, just to underline, need to understand that FinOps is actually not what a platform engineer would do. It's more than that. It comes with organizational and governance impact. It means that you have to talk to finance people, process people, business people. You need to educate the entire organization, right? This is like, if you think about FinOps, it's about explaining to everyone who wants to hear it or not wants to hear it, how does cloud costs work and how their actions impact cloud costs, but also to talk to techie and explain what their action means for the business. So FinOps is very wide. That's why we also wrote here that we talk about cost management. We really want to boil it down to manage the costs which you can deal with and touch, right? But if you're interested about more than that, then FinOps is the right framework to have a look into and understand the bigger scenario.
I guess this concept and like every practice built around FinOps kind of helped the cloud costs being handled proactively, I reckon, right? Because otherwise it's usually in the traditional way, you only act if something happens, I believe. But it's so the name sometimes feels a little bureaucratic, probably.
Talk with banking people, they're completely confused about it because
Really?
FinOps means in banking something entirely different.
Okay.
That's well, I was not a fan of putting behind everything in ops. I hope no one ever come off the idea to call it platform ops. No, please not.
So FinOps teams are separate teams, right? They're not embedded into platform teams.
Yeah. They are usually operate as an independent unit. But it also depends on, right? So sometimes they're embedded into IT teams. Sometimes they're embedded into procurement or CFO organizations. So it very much depends on who is the initiator most of the time for implementing FinOps itself. I always say, like, if you are a new CIO in a company, FinOps is a good way to get your first 100 days done because you usually will always find something that can be optimized. If you're an old CIO, never introduce FinOps because it will show your dirty history in IT.
It's like, there's this famous saying about Scrum framework. I know it's quite controversial at the moment, but there was a saying about Scrum that it's like your mother-in-law. It shows everything not working in your house. So I guess FinOps has a similar, result in organizations. And let's go for the implementing tagging strategy to uncover hidden costs. So you are suggesting there are hidden costs Okay.
There are always hidden costs.
Who is going to pay the hidden costs, Max? Tell me.
Luckily, it's never me.
I hope
No, I mean,
get that.
you will find it out, right? But
Yeah.
it also depends on how high are your costs, because there's this very funny area in some way, when you go with a company and you support them in their cloud journey. In the beginning, they're extremely picky about costs because they have no idea what does it mean, what costs do you cause. If you have a web company, you have millions of API requests, and you see all the API gateway costs spiking up at some point in time. You try to optimize this corner and so on. But at some point where you get bigger and bigger, people are still interested in it, but don't find time to really take care about the details. And then that's why you also, when you have discussions around the costs and you see talks, what do they really talk about? Data at rest, which server do I use? Should I go Intel? Should I go ARM? S3 bucket costs and so on. Yes, for sure, that's the big bill part of it. But next to it comes API egress costs, which usually are together already bigger than the third largest point on data at rest in an S3 bucket, right? And then depending on which organization or how you have built your environment, if it's like running on Lambda and serverless, yeah, hey, it's super cheap and fast and whatsoever. But your network traffic will spike up because you have extreme chatty environment suddenly, and you cannot cache and store something really, really good. I mean, there are ways to cache different calls, but when you follow along with a company that is not a digital native, they are not looking into that in the first step. And so, yeah, there's so many moving parts in it, that's why you need tax. Simple as that.
And I guess a tax strategy is coming up later. Yeah, but let's say you're using tax for a purpose, right? So you have to have good enough tags that I guess makes sense.
Yeah.
Also, you have to keep them to a certain length because you want to be able to, use them across different cloud providers or somewhere else. Then you really need to limit your tags as well, because too many you can't read them, you can't make sense of them. Too much granularity brings, right? Yeah. So
there comes a table in a
spot.
few pages or so.
Yeah.
Where we compare that, and the feedback which I got on that one was like, man, that was the most helpful little thing because I was absolutely not aware that this is anyhow a topic. And I was like, you have no idea how often systems broke because we hit limitations, then the tags were cut off because they were set automatically. You throw them wherever in a Terraform file or a biceps file, and you deploy something, and then it's a mess, right?
Yeah.
So you really, really need to know the limitations. You really need to know the special characters. Somehow people love special characters like crazy if they go and deploy something in the cloud. Case sensitivity also a thing.
This didn't occur to me at all. I never paid attention.
And it's confusing. And it's confusing because like most services which you want to spin up in a cloud, they are not case sensitive because they must be written small, and they maybe can have a minus in between, and that's it for the name of the service, right? But then the tag become case sensitive, and it's like,
Also down in your pipeline somewhere, sometimes teams outside of your team start adding tags without your control sometimes before you get to the artifact out, or like whatever Terraform module you're using, if it's a sub module somewhere or something like that, You just reuse a default tags parameter there and add yours. And then someone else does this as well. And then it becomes something that just doesn't look like anything.
Yeah, absolutely.
Yeah, so here's one sample.
Yeah, it's so typical one. We want to have as less as possible information, but we want to show the whole entire organizational structure in a tag. Yeah, thanks.
Yeah, accounts, departments, yes, cost centers, and then the your boss's name. I don't know, the project name. It goes on and on. Yeah, and there's this good chapter about defining tagging strategy.
Mm-hmm. Yeah, I mean, it's actually quite simple. Or what mean? Sometimes I even would not call it a tagging strategy. I would call it the failsafe. Keep it as short as possible, or keep it on the limits. So 63 characters is what Kubernetes and Google Cloud can only support. That might be changed at one day, but when we wrote the book, it was this. Only go alphanumeric. Only go with a minus and a under. I don't know, on a bottom laying minus. I have no idea. Underscore, yes. And that's it. This is really like the failsafe and move within these boundaries. I think we didn't catch up on how many of them you should have. That's also can sometimes become very much a problem. We have seen organizations, they want to have hundreds of tags. Yeah, try to find the right one. PII. That's a thing.
That must be a mistake, I guess.
Yeah. I mean,
have you seen this, Max? Just share. No names.
I know so much. I know so much about our customer environment. Sometimes T-shirt sizes and shoe sizes too. All tagged and labeled into the systems. But yeah, it's a problem. Indeed, if you do a security audit, you would run in a huge problem if you put there like that server belongs to Max Körbecher, blah blah blah. You need to go with user IDs, which are not trackable whatsoever, and
anonymized even. Okay. Yeah, so categories are this is a good practice to follow these categories: ownership, environment, project or product, cost center, compliance. Yeah, like
keep
PCI,
it easy, keep it simple.
Yeah.
They are also part of the recommendation from FinOps, right? But with this handful of tags, you should be always able to identify about which workload we are talking about. And that's most of the time good enough.
Yeah. So I was wondering if the tagging policies ever block deployments in CI/CD pipelines. Like, how do you enforce a tagging strategy, right?
Yeah. So I mean, this is like in the end one of the superpower, I would call it, for a platform engineering team, that you can write your policies around it and identify workload that is untagged. And either you block it, that would be the hard way, or you give a feedback to the product team and say like, hey, we have deployed it, but by the way, next time we maybe want to block it. That's, by the way, a very interesting approach one of our customer does. So if you violate once the policy, they will keep deploying the service and saying like, once is fine, here's your alert, you have to fix it for the next time. If you want to deploy it a second time, it will not go through.
That's actually a good way to teach the organization.
Yeah, right? Because they are understandable in some way, saying like, I got it. You maybe didn't read the 500 pages of introduction, what you have to do all. Fine. But now please fix it. And I mean, it's also very simple. If you play back to a team and say like, hey, look, please give your ownership and your data classification tag to it. There will be no big discussion, or normally not like, I do not like it or I don't know it because it's too simple information.
Mm-hmm.
But if you come with a too big catalog and say like, okay, no, you have to add 50 different tags, yeah, no one likes to do it.
Yeah.
But I also don't see it in the responsibility of a platform engineering team really to fix that problem. So this is really a shift left thing of like, you have to tell me what actually is this about. I just tell you if you fulfill our criteria or not.
Okay. So just because of the time awareness, I'm going to jump to the most exciting topic, looking at cost optimization strategies. Here you go, folks. This is why you want to buy the book. So I have a question actually. So I was chatting with an ex-colleague the other day, and since he joined, I think he is the platform lead or something. He decreased costs by 20%. I said, wow, okay, that's amazing. Like that, reducing 25% on cloud costs is incredible. But I've realized I forgot to ask where he started this job. How do you start when you join and like you said, a CIO, if you're a CIO and you want to start your FinOps journey or like optimization journey, what happens?
Well, there's a political answer and there's the max answer. I always be so
It depends.
cheeky. No, I leave the consultant here completely out of the corner. It's almost in the weekend.
Yeah.
I always say just use the brain. Just think about what you do and what you have done, and does it really make sense? Like if you think through things once, and then we come back to the famous rubber ducky, or meanwhile ChatGPT or Claude or whatever, with which you can chat about your problems, you will maybe come to the point in realization, ah, damn it, what we are doing here is really causing a lot of costs, but it maybe even doesn't solve the problem which we tried to solve if we think it through, because XYZ comes up. The other thing is very often we see this process problem. And that's where I also often feel like my team is fantastic engineers, but no one of them are like process engineers. They do not have a process analytical background whatsoever. But when we talk about optimizing deployments, optimizing platforms, how we can make more things more reliable, and so on, we always talk about the processes. We never talk about the technology. We don't talk about technical depths or the decisions which we have taken at that point in time. Most of the time, the problem comes first in is the process is bullshit.
Yeah.
And if we just simplify the process or find other ways to fulfill what we got asked for, we can save also money in that.
Yeah. Also, then there is the concept of the best deals, right?
Yeah.
But then how do you just buy, because you got a better deal, like just all of a sudden change? Yeah, can you just give a little bit of a run through for this?
I mean, it's a fairly short chapter or piece of mind here. The thing is, like, also there, it very much depends on large enterprises have usually deals with cloud provider. So it's not an easy one-to-one comparison. We have done this a while ago for one customer where we did the checkup if it makes sense to migrate everything to ARM, because ARM is always considered as cheaper and faster and better and whatsoever. But because of a few different leverages in this whole thing, starting by a custom contract, starting by the migration costs, going down to that there are some different saving plan options in the room. And saving plans do not work with every type same. So a saving plan on an Intel machine is way more efficient than a saving plan on an ARM-based machine. which boils down that the cost difference, if you leverage all of that, is not that big.
Mm-hmm.
And then it's a question for 2, 3, maybe 5% at best of costs which I can save. Do I want to do all the other thing around? Or do I leave it where it is and just say, in future, just use ARM for everything else?
Yeah.
Right. So that's a few things which we always need to consider. For sure, to make the planet better, it would be always good to go to the more energy friendly, more cheaper things. And I mean, with like an ARM server, if you go cheap, you don't have to buy twice. ARM is very good in that.
I actually forgot to share one project. If I can find it. It was quite interesting. Wait, I will find it at the top. Yeah, no, here. Note. Yes, KEIT. I don't know how to read it. Kite. I don't know. By Agnostic. This is a cool open source project to actually understand. This is mostly for Kubernetes, though, to the environmental impact of your application. It's let me share this one if I can. So yeah, it's quite interesting. Kubernetes emissions insights tool. I once saw a presentation of the maintainers, and it was really it looked really accurate, to be honest, and it also showed how the regions, might impact this as well. But let me quickly switch back to the book.
Yeah, in terms of sustainability, it's well, for some reason I have once founded the technical advisory group for environmental sustainability because I also find the challenge on it very interesting. But the problem is that we do not have this punch through. So on the bottom layer, you always depend on the provider giving you accurate information, and on the top layer, you must analyze it, and everything in the middle is a big blind guess.
Yeah.
That's nothing which we right now really seeing
designed
solved.
things for, or what? I don't know.
Yeah, there's no movement in it. So always hear people talking about it. Oh, it's my hard topic to build sustainable systems. And I need to say I've met so many heartbroken people that understand after 5 years, no one is working on it. Like to solve the problems which blocking us for moving along. But nevertheless, we still need to find ways to be better in what we are doing IT-wise, and that's a perfect chapter for it. Some highest utilization and lowest demands. Even in the Kubernetes environments, we still talk about that we have over-provisioning of nodes, right? I think one of the first chapters we also talked about like how big is actually the footprint of Kubernetes in every single node, for example, and what is the right node size. So small nodes are actually stupid. Also, they can be more of them and it's easier to scale and whatsoever, but they have a lot of downsides. But always go to big nodes is also stupid because of you do not utilize them. Right? And they have this energy curve that if you utilize them around, like, let's say 50%, they eat already 85% of the electricity. So if you go the other 50, and this is actually a lot. There's also discussions about, but newer servers are better in this energy curve. Might be, but we are most of the time not having the most used servers. All of the servers in the data center got extended by 2 additional years. And the latest machines still don't have a linear growth of CPU utilization and energy demand. So it's still more
put the AI wave on top of it. I don't want to say anything else. I guess. I think
Carpenter
it
is
was
also
a few.
one
I think
thing.
it was a few years ago. I think the cloud industry caught the aviation industry in terms of carbon footprint.
Yeah.
Maybe 3-4 years ago,
Yeah.
and so we must be way ahead, I guess.
Yeah, that's another problem. You really don't know it. So the study everyone is pointing out in this regard is from 2017. Actually, was published 2018 and was revision 2019. So if you put these numbers up, it is believed that we are way far ahead of that, but no one ever did in the last years the calculation for this one. There was a German calculation done from the NGO for IT companies whatsoever. It was miserably wrong.
Okay.
Completely like, no, that can't be if these numbers doesn't fit together. So yeah, there's a lot of research in this part to be very precise in it.
Yeah. Victor says, I think on this topic you might have added Carpenter or another third-party vendor cost optimization tool.
Yeah, we somewhere talk about sustainability, where we also shortly point out to Carpenter. Also, Carpenter is in the Kite tool, the source of truth for most of information. Nevertheless, Carpenter also just it reads what it can read from the server. As soon as there's a virtual machine in between, it's guessing or using an AI model to roughly tell how much it is and so on. But yeah, this is the problems which I was talking about, that there's no real solution provided, because you need to put the solution into the server, into the hardware layer, and provide that into the software.
So I know we've kind of hit the top of the hour. So anything you want to say about this last bit? That is actually really important, but yeah, something you want to mention.
Yeah, I mean, like the auto scaling topic and get the scaling right or rightly done. It's actually not an easy one. I also like this engineering challenge because we usually talk about CPU and memory, but that it also become, especially in cloud provider environments, relevant that we're talking about the node size, and suddenly we talk about IOPS and storage capabilities and other things like that. So it's fast, very fast layers up.
Yeah.
Else,
yeah,
I mean,
also predictive versus reactive scaling models are there as well.
This is actually an important one because we, as I said also earlier, usually a cloud provider needs kind of long to spin up a new node. So if you are reactive and your system is almost dying, it's too late. You need to understand your market, and that's why we also put so much focus on observability. You need to understand your market, your cycles, when something grows, and maybe spin the one or other node up before you get hit by it, if it is important for you that your system is stable, right? Because also there, what sometimes when you have misconfiguration and your Kubernetes cluster is spinning up too slow, then it maybe spins up too many nodes, and then you need to cut down some of them again, and it can become very costly to be too much over provisioning in this case.
Yeah. I once heard in a meetup that one platform team said, I don't know why they don't fix it though, in their 100 cluster, probably smaller clusters although, model, their clusters were usually 80% unutilized.
Burn the money.
Yeah, they didn't seem to care that much.
Burn the money. But 80 is really hard. I mean, with 80% underutilization, you can cut down half of the system, and your system shouldn't care at all.
Yeah.
But from that money, you can do good things.